Myself, Dr. M. Lakshmi Prasad, working as an associate professor in the Department of Data Science in Institute of Aeronautical Engineering. So, in this video, I'm going to discuss about what are the various forms and patterns of missing data. So, in previous videos, I discussed what is the missing data, then what are the various forms of missing data, and then what are the various methods that are available for handling the missing data, and then that and all will be discussed in previous video. So now in this video, I can able to explain what are the various types and various forms and various patterns of missing data we will see in this video. So very first we know that what is a missing data. So in statistics, the missing data or missing values can occur when no data value is going to be stored for a variable in an observation, right? And this situation is mostly going to be occur as a result of manual data entry procedures and then equipment errors and incorrect measurements, right? So everyone know that in statistics there may be a chance of getting the missing data. It may be in the form of value, and then how are going to handle this missing data, right? So all the time these missing values may occur whenever no data value is going to be stored for a variable in an observation. So right, this situation is mostly going to be occur as a result of that manual data entry procedures. So sometimes the users may able to forget to enter the value or can able to enter the wrong value, or right, and then some equipment errors also going to be occur, and then incorrect measurements also going to be occur, right? Through the measurements what I'm taking. Suppose if I'm going to take some values through measurements, so sometimes the measurement due to some issues, the measurement devices may able to read the incorrect data. Suppose reading the temperature of the fever, right? Suppose if the battery is low, what will happen? The device is able to read the wrong data, even though some persons were having that fever and all, right? And then equipment errors, right, showing the wrong results. So these and all some of the forms of missing data, right? And then what are the problems you are going to face with this missing data? So through that, loss of efficiency may occur, and then the complications is going to be difficult one in handling that and analyzing the data. So analyzing the data is also going to be different, whether it is a correct one or right one, or some other value it is having that logged. And then the bias also will occur due to that. So the differences between the complete data and missing data also be may occur due to this. So these are some of the problems of missing data. So first one is the lot of loss of efficiency, and then the complications are going to be difficult in handling this missing data, and analyzing the data also going to be difficult, and bias also be there. So while taking the differences between that missing data and complete data. So next, what are the various forms of missing data? So in various forms of missing data will be unit non-responsive missing data, and then item non-responsive missing data, or I can able to treat it as an latent variable and unobserved variable like this, right? So unit responsive missing data means, suppose if a row is having multiple missing values. Suppose this is the row, so record number 1 is having some missing value here, and here also some missing value, and here also some missing value. So if a row is having multiple missing values, more than of one containing more than one missing value, then this entire row can able to call it as unit non-responsive missing data. And sometimes the missing data may also occur in one particular record number 3, and then record number 4 also having some missing value, and here also having some missing value. At the time what I have been able to treat it, that type of missing data will be item non-responsive missing data. So item non-responsive means where the missing values can occur in anywhere in the table. At the time that kind of missing data will be considered as an item non-responsive missing data. Similarly, when a variable is having some missing values like this, so the variable is having some missing values in column wise, at the time I can able to treat this entire column as a latent variable, since this variable is not having is having more missing values when compared to the other variables. So based on this, I can able to define this variable as a latent variable and unobserved variable. So like this, I can able to deal this missing data into different types. So first one is unit non-responsive missing data, and then item non-responsive missing data, and then latent variable. So if an entire column is having more than one missing value. Next, most of this dealing with missing data has going to be a challenge in data analysis itself. So what are the problem we are going to do? So first we have to identify the problem, and then we have to perform the analysis, and then we are going to move on to the design. After that we have to do the next step, right? So in the data analysis phase itself, we have to identify where the data is missing, so that the rest of the process is going to be very easy. So for this, how are going to what are the methods that are available? So what kind of features that the method is available? So like this, first all the methods what we're having for handling the missing data all the time should be minimize the bias and maximize the use of available information, and then all the time we have to get good estimations of uncertainty. So what are the methods we're applying for this missing data? So what you have to do, that method should minimize the bias, so the error rate should be very less, and then maximize the use of available information, and the estimations and the uncertainty estimation should be very good, like the p-value I'm going to take or confidence interval. Like this, some based on some factors I can able to calculate the uncertainty. So based on that I can able to estimate it. So what kind of uncertainty, what factors it is affecting, like this, right? So in order to handle this missing data, we're having different types of methods. In further slides I can able to explain this. So then what kind of missing data should be modeled, right? So if an item is missing from your data set, but you can able to suspect that it has a true value or not, right? So whenever we're going to gather the data from multiple sources like primary and secondary, so we're getting some values, right? Suppose I'm going to fill this table which is having some rows, and I'm getting some value here, right? So whether what the value what I'm getting for the record 2 is it a correct one or it may be a wrong one, I want to find out. So how we're going to model that kind of missing data? Suppose if an item is going to be missed from the data set, so how we're going to suspect it, watch that is a correct value or not. I don't know might simply mean I don't know. So I don't model if there was a true value. So whenever I'm getting this is the correct value, so I can able to skip this model. Suppose if this is not a true value, then I have to model it. So model should be model it as a sensor inflated. So this is one of kind of example I want to model it. And then attraction. So that means do you want to model the dead people? So for that, what I have to do, I have to well-being of people being people who died, and consumer behavior of the people who died. Like I want to model that kind of information. So at that time, what I have to do, I have to the well-being of people. So even though the health conditions is good, so the person is going to be right. That is one type of gathering data, and then the consumer behavior of the people uh, who died. That is another model of people are going to be model. Like this I can able to gather the information. So this is one type of case, this is another type of the case. So what is the information we are gathering, so that should be whether it is a true value or not, I have to identify it. And then the distribution of missing data. So the distribution of missing data is going to be done based on the missingness nature I can able to identify. So consider example on the left side. So here I'm having an table having ID of row columns as Q1, Q2, and Q3, and ID number as 456, 57, and then 58, 59. So right. So here I'm getting the missing value here for 457 of Q2 column, and then here also I'm getting the missing data in Q3 for the ID 459. So then how can able to identify whether this should be a item response to missing data or unit response to missing data? So this should be an item response to missing data here. since I'm getting missing values from 457 and 459. So the missingness occurring here, and here also I'm getting the missing. So this and all will comes under item non responsive missing data. So similarly, next one, suppose if I'm going to here, the table is containing only zeros and ones, right? So at the time here any data is going to be missed here. No kind of data is going to be missed, since it can able to fill either zero or can able to fill with one. So that type of missingness, what type of it is missingness, we have to identify. So for that, we are having some mechanisms. So previously I told some of the methods that are available for handling the missing data. So what are the methods that are available? So first one is MCAR, and then MAR and NMAR. So these are the three types of mechanisms available for handling the missing data. So MCAR means the full form is that missing completely at random, and then MAR nothing but missing at random, and then MNAR is nothing but not missing at random. So like this, we're having three types of methods for handling the missing data. So very first one is that MCAR. So MCAR is nothing but it is very rarely going to be used, and then you can able to make testable of this missing data through this method. And the next one is that MER is nothing but missing at random. So here, what you have to do is here the variables are going to be taken out, and then have to identify the predictness, and then theoretically you can also able to assume MER, and then you can also include the variables that will satisfy. Auxiliary variables are going to be identified here, and no need of testing is going to perform missing at random cases. And similarly, not missing at random cases, so the missingness depends upon only on its own value. If you have this, what will happen then? Usually you have a problem of this AR, not missing at random cases, right? So these are the methods that are available for handling the missing data. So MCR, missing completely at random. So that means that, so here we are going to be identify the very rare cases missing completely at random. So the value what we are taken out, that should be tested thoroughly, and then you have to fill them with the missing data. MAR, nothing but missing at random. So here we have to be take it out the variables of the model, and then we have to predict this what kind of missingness, whether it is comes under item non-responsive method or unit non-responsive method. Like this, we have to identify it, and then so then we have to theoretically have to assume this MAR, and then we have to fill some auxiliary variables which is going to be satisfied and then testable one. And then MNAR, there's nothing but not missing at random, or MNAR or NMAR, like this I can able to call this method. But here the missingness is going to be depend upon its own value, and then if you have this type of method you are going to be used, then definitely you have a problem for that application. Next, if you see in detail about missing completely at random. So here the values in the data set can miss completely if the events that lead to any particular data item missing are independent of both observed variables and then unobservable parameters of interest and occur entirely at random, right? So this kind of method, the values what I am going to take in the data set can miss completely at random. So whenever the events that may lead to any particular data item is missing, which are going to be independent, right, of both observable variables and out of unobservable parameters of interest, and occurring is going to be entirely at random type, right? So that should be about missing completely at random. And missing at random means, so there should be an alternative method of that one. So where it can able to, it occurs whenever the missingness is related to the particular variable only, but it is not related to the value of that variable, right? So missing at random means, so here this should be entirely alternative methods, and this one is going to be occur whenever the missingness is related to the particular variable, but it is not related to the value of that variable that has a missing data. So example of this one is accidentally omitting an answer of the question is the one of the example of missing at random case. And the next one is that missing not at random. So this is the other method. Which one is related to uh, ignorable missing cases or non-ignorable missingness. So there are the two types of missingness is available. So the very first two will be related to ignorable missingness mechanism, and this one is related to non-ignorable missingness mechanism. So here the data for this method is missing for a specific reason, and right, so that is the value of the variable that is going to be misrelated to the reason. So based on some reasons the missingness is going to be deleted. At the time only I can able to apply this kind of method. Example, if the certain question on the questionnaire tend to be skipped deliberately by the participant with certain characteristics. Suppose the interviewer is going to ask some questions, so at the time what will happen, the respondents can or participant can able to skip that question deliberately without some with some certain characteristics. So like that kind of problems will come under missing not at random. See some assumptions what have to be considered for this method MCR, MER and MAR. So when they are going, so here MCR means missing completely at random. So the probability of missingness is unrelated to the values of the any variable. Okay, and then missing at random is the one. So if the missingness is unrelated to the value that is missing, but it is related to the values of the other variable. Example, the question about the particular number of hours spent browsing the internet might be missing more often than for the married than the unmarried participants. So this is the question I'm getting. So the typical number of hours spent browsing the internet might be missing more often for married than unmarried participant. But so among this married subset, so the missingness is completely random, not related to how many hours the person browse. So this is the example of this data missing at random. So and then missing not at random is the case if the missingness is related to the value that is missing and is often to the values of the other variables as well. Suppose if the missingness are more prevalent among those who are typically browse more than those who browse less. This is comes under example comes under missing not at random case. So these are the methods available for handling the missing data. MCAR, MER, and then NMAR. So the first two methods, what we're having comes under ignorable missingness, and this one comes under non-ignorable missingness mechanism. So like this, we are going to classify two types. So ignorable one and non-ignorable one. So here the first one is that missing at random, completely at random. So missing completely at random means so the probability of missingness is unrelated to the values of any variable. So missing completely at random. So the probability of missingness is unrelated to the value of any variable. At the time I can able to apply this method. And next one is MER. So here if the missingness is unrelated to the value that is missing but it related to the values of the other variable. So if the missingness is unrelated to the value of right, but if this is related to the values of other variable, at the time I have to make use of MER method. So example, the question about the typical number of hours spent browsing the internet must be missing more often for the married than the unmarried participants. So in browsing the internet in the internet browsing center, there may be a chance of coming the married people and unmarried people, right? So I want to find out how many number of hours the spending by those people. So here the missing completely at random is not related to the how many number of hours the person is browsing. So that is the case here. And the next one is that missing not at random is the case. So if the missingness is related to the value that is missing and often to the values of other variables as well, right? If the missing is related to the value itself, but previous one should be unrelated, but here it is related, and the values of the other variable also. At that time, I have to make use of this uh, missing not at random. So here, this one is unrelated case, and this one is also unrelated and related case. So unrelated, and second one is related to unrelated, and then related to the other variable, and this one should be related to the variables and other variables also. So these are the types. So here the missingness is unrelated here, and this one M is related unrelated to the value and related to the other value. So it should be related. So related to the both. So example here is missingness values are more prevalent among those who typically browse more than among those who are browse less. And these are the some of the methods for handling the missing data, right? So here deletion methods, so deleting the case of variable that is missing. So deleting methods means here what we have to do is, so suppose if the table is missing some data, so then how are we going to apply this method, deletion methods? So I can able to have three types of methods: list wise deletion, pair wise deletion, and variable deletion. Similarly, I'm having some substitution methods also. I can able to apply through single imputation and multiple imputation. In single imputation, I have some of the methods like mean imputation, conditional mean, case mean, regression, last observation carried forward, worst case imputation, and best case imputation. These are the methods I am having. Suppose if I am having a table, so this should be ID, and this is Q1, Q2, Q3, Q4, and Q5, 10, and these are the values I am having. So first one is that list-wise deletion method. So list-wise deletion method means, so when I'm having, so when I'm having a method, list-wise deletion method. So this method is going to be applied only whenever I'm having the missing values. So that rows is going to be deleted. That should be list-wise deletion method, right? And then so next with pairwise deletion. So pairwise deletion means when I'm having the missing value of two consecutive rows, at the time I have been able to delete one of the missing data. And variable deletion means, so here suppose here also I'm having the missing data. So I'm having the missing data for variable Q2 and then Q3, Q4. So among this I have to identify so which variable is having less preference or less importance according to the application. Suppose even though the Q3 is having two missing values, but the Q2 is having uh, less importance, so I can able to delete this variable, right? So variable deletion means based on the importance of the variable of the application, I have to identify. So whether Q2 is having more importance or Q3 having more importance or Q4 is having more importance. Suppose if Q2 is having less importance and Q3 is having more importance, so at that time what I have to do, I have to delete Q2 itself even though it is having less importance. So these are all the methods of the deletion type. And the next one is substitution. How can able to fill the missing data with the some other value I can able to do. So for this first one is mean imputation. So mean imputation means, so suppose if I am getting the missing value here, right? So for this what I have to do, I have to calculate the mean of this value. So what is the mean value of 50, 60 and 50? Suppose if the mean of this three will be about 55, so I can able to fill with this value with the missing value. Similarly, I have to carry it out the mean value of this one and what is the mean I'm getting, that one is going to fill with the missing data. And next one is conditional mean. So conditional mean I can apply. So based on some conditions, right? Suppose if the mean value is greater than 50, I can able to fill with 55. If the mean value is greater than 60, I can able to fill with 65. Like this, I have to write some conditions. So based on that, I can able to fill with the missing data. And some next one is that case mean. So case mean is that I can write some case statements. So I already have some idea how to write the switch case, right? So if the case is matching, I can able to fill with this value. If the case 2 is matching, I can able to fill with the statement what I have written in case 2 and case 3, like this. So what is the values I'm having, that one is going to fill with the missing data. And then next one is that regression method. So regression method means here I'm going to use some mathematical equations. So based on that, I can able to fill it. So suppose Q1 plus Q2 into 0.3 and then Q4 into 0.4, like this I can able to write if Q5 equal to. So I can able to fill, suppose the Q, I have to fill the value here. So for that, what I have to fill the substitution values of 40 plus 50 into 0.3 plus suppose if it is 10 and then 10 into 0.4. So the value, suppose if I'm getting is 10.32, so that 10.32 is going to be filled here. Like this, I can able to fill with the regression imputation. And next one is that last observation carried forward method. So here I can able to fill with the previous value what I'm getting. I can able to fill, or I can able to take the average of previous two. So 50 and 40 and 50, I have to take the average. So the value what I'm getting, suppose 45. So that value is going to fill with the missing. That should be our last observation carried forward. And next one is that worst case and best case imputation. So what is meant by worst case and best case imputation here? Suppose here is the value I'm getting. So this is the missing data. So this data is going to be filled according to the worst case means. So I have to take the least value as the worst case and highest value I'm going to take it as the best case. So what is the least value? 100. So I can able to fill with the least value. Similarly, if the 103 is going to be taken as the best case, I can able to take this with the missing data with the best case. 103. Like this, I can able to handle this missing data through worst case and best case. Right. So these are the methods that are available for handling the missing data here. Right. So missing data. So in statistics, the missing data or missing values occur due to the no data is going to be stored in the variable based on observation, and all the time this missing data is going to be occurred due to manual data entries and then equipment errors and then incorrect measurement. So these are the types where can able to get the missing data, and then the problems of this missing data will be loss of efficiency and then complications handling will occur, and then analyzing the data is going to be difficult, and then bias also be one of the problem of missing data. So the missing data patterns will be of three types here. So first one is unit non-responsive. So whenever the row is having more than three missing values, more than one missing value, then that row is going to be considered as unit non-responsive missing data. And the missing data what I'm getting in some other rows and then columns, that one should be considered item non-responsive missing data. Suppose if entire one column is having contain more than one missing value, that should be treated as latent variable and observed variable. So these are the various forms of the missing patterns of the missing data. So what kind of missing data is going to be modeled? So what are the ways for that one? So here the distribution of the missing data is going to be considered very important. So what type of missing, whether it is a ignorable missing mechanism or the non-ignorable missing mechanism, I have to identify. So based on that, I have to distribute the missing data. And what are the methods that are available for handling this missing data? So missing completely at random is one of the best method. That should be related to the missing completely at random cases, and MER means missing at random case where you can able to identify the predictiveness and you have to fill the missing data with the auxiliary variables. And not missing at random is the ways mainly depends upon its own value itself. And missing completely at random, so is the one, so whenever we are going to be identified, the unobservable variables and the independent variables is going to be identified. And missing completely at random is one of the quite alternative method. So all the time the missingness is related to the particular variable, but it should not be related to the other variables. And missing completely not at random is completely related to the variables of the variable, and also it also be related to the other variables of the values, right? So the probability of missing should be unrelated in case of MCAR, and then the MER should be unrelated to the same value of the variable but not related to the other variable. But MNAR should be related to both variables and then other variable values also. And these are the methods what we're having for handling the missing data. So deletion methods and imputation methods. So list-wise deletion, pairwise and variable deletion should be the deletion of methods. And single imputation, multiple imputation, these are some of the substitution methods. So where the single imputation methods like I can able to fill the missing data with the mean imputation and conditional mean imputation and regression imputation, last observation carried forward, and then worst case and best case imputation. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.